In this example, we want to find all critical points of the function f of x, which is x cubed minus x squared, and then determine where this function is increasing and decreasing. So to do that, we start by taking the derivative, and we get that our derivative here is 3x squared minus 2x. This is a polynomial, so it never not exists. So the only way I get critical points is when this is 0. So I can set this to 0, and then I can factor out the x from both terms. We get x times a 3x minus 2 equals 0. Look at these factors separately. Here, this tells me that I have a critical point where x is 0. And here, I get one where x is 2/3, because that will make this term here go to 0. So my two critical points are at 0 and 2/3. I can then draw a number line for this. And I want to look at plugging things into the derivative, which I'm going to use this factored form here for. So if I plug in -1 to the factored form, I get a -1 times a -3 minus 2 is -5. That's going to be a +5. So I'm going to get a positive number over here. If looking to plug in 1/2, I will get 1/2 times 3/2 minus 2 is plus times minus is a negative sign. And if I plug in 1, I get 1 times 1, which is a positive number. So we're plugging this into the first derivative here, and plugging into the first derivative will tell me if the function is increasing or decreasing based on whether the first derivative is positive or negative. So we know that the function f is increasing wherever this first derivative is positive, so that's on the lower part from -infinity up to 0, and then from 2/3 up to infinity on the upper part. And we know that f is decreasing on the part in the middle from 0 up to 2/3. And again, we know that from our work above, our critical points are at 0 and 2/3. So that's the idea of how we can use the derivative to figure out where critical points for a function are, as well as where this function is increasing and decreasing.